So the topic of today's presentation is kernel in machine learning, concept, importance and applications. So what is basically a kernel? Kernel is a mathematical function which is used in machine learning algorithms. And what does it do? It transforms data into higher dimensional spaces. And finally, what is the purpose of a kernel in machine learning? The first purpose is to solve complex non-linear problems in machine learning. And further, it also enables algorithms to draw more accurate boundaries between data points. So coming to the importance of kernel functions. Kernel functions are very good at handling non-linear relationships with data, which are very common, and it makes it hard to separate classes using simple linear models. Now, secondly, the kernels allow machine learning algorithms to handle this complexity without needing manual feature engineering or without the explicit knowledge of use cases. And third, these use cases are classification, regression, and pattern recognition. So, what are the different types of kernel functions? These are linear kernel, polynomial kernel, radial basis function, and sigmoid kernel. So, different kernel functions offer various advantages depending on the type of problem. So, for example, RBF is highly effective for separating non-linear data, but computationally expensive. Now, coming to the applications of kernel methods. Now, these are the following applications. First is support vector machines, then image recognition, natural language processing, bioinformatics. In support vector machines, kernels are crucial for finding hyperplanes that separate data in higher dimensions. While in image and text recognition, kernels allow machine learning models to capture subtle nonlinear features like image distortion or language nuances. Now, focusing on the kernel methods in support vector machines. And in support vector machine is an effective algorithm when data isn't clearly separated in 2D or 3D space. While the kernel trick makes this algorithm more powerful. How does it make it more powerful? It allows it to perform well in higher dimensions without the computational burden. Now, what are the benefits of kernel methods? Kernel methods reduce the need for labor-intensive manual transformation of features. And secondly, they generalize well across diverse problem sets due to their adaptability in handling different types of data and patterns. Now, concluding this topic of kernel in machine learning, the key takeaway is that kernels allow for classification of more complex data structures that simpler linear models fail to capture. Secondly, their relevance continues to grow with the increasing complexity of modern datasets and machine learning tasks.